Okay, this is 6.2 homework help. First problem wants us to add these two vectors u and v together. Now when we add vectors, we just add the x components and add the y components. So 1 plus 1 gives us 2, and negative 1 plus 2 gives us 1. So that's our answer for the first one. When we subtract vectors, we do subtract. So 1 minus 1 gives us 0, and negative 1 minus 2 gives us negative 3. When I multiply a scalar negative 3 times a vector, you just basically distribute, and that's going to give us negative 3 and negative 6. Now the dot product between u and v would be when you multiply the x coordinates and the y coordinates and add them up. So x times x is 1 plus y times y is negative 2. When you add them up, you get a number, negative 1. And then we want the magnitude of v. To find the magnitude of v, we can graph it and just use the Pythagorean theorem because it's just the distance of the hypotenuse. So it's just x squared plus y squared, which would be 1 squared plus 2 squared, which is the square root of 5. Okay, the next problem says that a child walks on the deck of a ship at 5 miles per hour east, and the ship is moving at a speed of 10 miles per hour north. Find the speed and the direction of the child relative to the surface of the water. So what we're going to do is place both these vectors that they gave us on an ordered pair here. So it doesn't matter where you place vectors, right? Because all that matters is the direction and the magnitude of them. So this one's up 10, and the other one is over 5. So I'll place them here. But when you add them, I can move this one up here, or you can make what's called a parallelogram. And the resultant, when you add vectors together, is always the diagonal of that parallelogram. That's the parallelogram rule. So you can place these vectors anywhere you want, make a parallelogram like this, and as long as they're pointing the same direction with the same length. Now the magnitude is what they're looking for, and the angle, which I can find. First I'll find the magnitude by doing the Pythagorean theorem. So that'd be 5 squared plus 10 squared equals c squared. That's 125 equals c squared, square root. You get c equals the square root of 125. That can go right here. Now they're looking for the angle as well. Now they want the angle from north, so they're talking about this angle right here. Okay, so that's my angle I'm looking for. So when I do that, I'm going to do tangent is opposite over adjacent. So I'll do tangent of that angle equals opposite over adjacent. So I want the inverse tangent of 5/10 or 1/2 to give me my angle. Now make sure your calculator's in radian mode because it does want radians here, but that will give you the right answer of about 0.4636. Okay, the next problem says a woman exerts a horizontal force of 3 pounds, as I've drawn here, and she pushes a box up a ramp that's 7 feet long at an angle of 30 degrees. We want to find the work done. Now, the book gave us the formula for the work, or I gave us in the notes. Work equals force times distance, and the key to this is that the force that you're using has to be in the same direction as the distance that you travel. So in this case, that force is horizontal. We need to find the force that she's pushing along the ramp. So I would place this vector down here. It doesn't matter where you place vectors, so I'll place this force vector down here. And what I'm looking for then is the portion of that force that actually goes along the ramp. So I can make a right triangle out of this and split this into what I would call x and y. X being the component of the 3-pound force that goes against the ramp, and y being the component of the 3-pound force that pushes against the ramp. So we kind of if you add x and y together, the resultant would be the 3-pound force. So you can go back the other way and split 3-pound force into both its two components, x and y, as if the x-axis and the y-axis go this way. Now it's kind of weird. Those of you that have taken physics are more comfortable with this probably because you've done that a lot, but you're going to need to get used to vector projection like that, where you have to break up a vector into two components. So once we do that, we can easily find, this angle is 30, so you can find x by doing the cosine of 30 equals adjacent over hypotenuse. Multiply both sides by 3. Now make sure your calculator is back in degree mode because you're using a degree here. And if you do that, you'll get 18. This then goes in for the force that we use. So this is 3 cosine of 30. And then we still have to multiply by the distance. And the distance we travel is 7 feet. And if you do that, you'll get your answer of 18.1. And the units on that are foot-pounds. The feet come from the distance and the pounds come from the force. So we can say foot-pounds. Okay, the next problem wants us to find the dot product of A and B, actually. Which, to do that, we're actually going to use this formula, which is the angle between two vectors. because the dot product is right here. So that's the quantity we're looking for. And they gave us the angle and they gave us the magnitude of both the vectors. So this formula actually works quite well for us right now. So what we have is the cosine of the angle between the two vectors, which is pi over 4, 45 degrees, equals the dot product. I'll use a and b instead of u and v because that's what they use. And I like the little hats over it, but they're using the bold letters, which is fine. And then the magnitude of a times the magnitude of b. So all I have to do is, fill this out. The magnitude of A is 14. The magnitude of B is 10. And I'm looking for this quantity right there. So all I have to do is multiply both sides by 14 times 10 to get it away from the denominator. And make sure you're in radians if you use pi here, or switch that to 45 degrees if you want to be in degree mode. But whatever you do, the product that you get, the dot product, should be 98.99 about. All right, the next problem wants us to find a unit vector in the same direction as this vector. So all we do is find the magnitude and divide the magnitude in this vector. This vector goes over 10 and then down 2. So we're looking at this vector here. All I have to do is find the magnitude, which is the square root of 104 if you do the Pythagorean theorem. And all you have to do is divide. So you have 10i. So you end up with this right here. Now it will be a unit vector that's in the same direction. It's only 1 unit long. Okay, the next problem wants to find the angle between two vectors, these two vectors a and b. I'm going to use this formula. So I have the cosine of theta equals the dot product, which is x times x, which gives you x times x is 0, plus y times y is negative 7, all over. Then the magnitude of a is the square root of 3 squared plus negative 1 squared, all square rooted, which gives you 3 plus 1 square rooted, which is square root of 4, which is 2. And then I need the magnitude of b, which is the same thing. X coordinate squared plus y coordinate squared square rooted, which gives you the square root of 7 squared, which is obviously just 7. So I end up with the cosine of theta equals negative 7 over 14, which is negative 1/2. I can do the inverse cosine of negative 1/2 to get the angle, and the angle will be 120 then in degrees. But they want it in radians right here, so I need to make sure I convert that by multiplying by pi over 180. And 60 goes into this 2 times, into this 3 times, so it's 2 pi over 3, and I can enter the answer as 2 pi over 3 like that. Okay, the next problem wants us to find the component of B along A and then the projection of B onto A. So this first one, we're actually not going to do this. I didn't put this formula on the formula sheet, but that formula is the dot product of x times V, or I guess in this case A and B, divided by the magnitude of A. So there's the formula for the component. If you do that, you get like 1 over the square root of 5 or something like that. Negative 1 over the square root of 5 in my case. But like I said, we're going to stick to projections of A, or projection of B along A, which that formula is right here. Now, obviously, you can change this. So we have B right here, and we have A right here. So wherever there's a V, I'm going to put that an A. Whenever there's a U, I'm going to put a B. So this is the formula I'm using. The dot product between the two vectors would be in the numerator here, which is negative 5 plus 4, which is negative 1, over the magnitude of A would be the square root of 5, if you do the magnitude of this, and that's going to be squared, so that just turns into 5. And then I need to multiply that by vector A, 1, 2. So the answer ends up being negative 1/5, comma, negative 2/5. So this is a weird one to draw and show you, but vector A goes up over 1, up 2, and vector B goes back 5, up 2. So what we're looking for is the projection of vector B onto vector A, which is actually this little vector right here. So it's kind of like breaking up B into its two components, and we're looking for the component that goes along A, or in the same direction as A, which is right here, this vector. It's just a little tricky to see from that picture, but we'll do other examples that'll make more sense, hopefully. Okay, this problem wants us to do some operations here. I would first write out what U, V, and W are from the graph. So here they are. Now when I add U and V, it's easier to do it this way. That gives me 2, 4. Now when I do 2U plus W, I like to write it out like this. Distribute 6, 4, plus 3, 1, and that gives me 9, 5. All right, 3V minus 6W, same thing. Solve this and you get negative 21, 0. And the magnitude of W is the square root of 3 squared plus 1 squared, which gives you the square root of 10. So hopefully you find this problem pretty easy. Okay, the next problem, we want a unit vector from the point 1, 2 right here to the point 5, 5. So we're looking for a unit vector that goes in this direction. Now what we can do is just take this vector right here and divide by its magnitude to find the unit vector. So this vector goes over 4 up 3 from point P to Q. And to find a unit vector, you just divide by its magnitude. Its magnitude is going to be 16 plus 9 square rooted, which is square root of 25, which is 5. So just divide by 5, and there's your answer here for a unit vector along this direction right here. Now what's nice about that is when you want to find a vector of length 15 in the same direction, you can just multiply by 15. Just multiply by 15 and put that answer here. Okay, the next problem is a tough one. I'm going to graph this. And it says we have a force of negative 25J, so I'm going to draw that down here. This goes down, this would be negative 25, or just that length would be 25, straight down. And we have another vector V. I'm going to draw this a little bit bigger than what it probably is, just so I can look at it. It goes down, or over 3 down 2. Okay, so we're looking for the component of F parallel to V. So here's V, and here's F. I'm sorry, the way around. Now, I'm looking for, the component of F along V. So what I can do is I can actually split F up, and I know it seems weird, but into two components like this. One component that goes along V and one component that goes perpendicular to that, because I could add those two vectors up to get vector F. So what I'm looking for is basically this one right here. The component of F parallel to V is that component. Now, there's different ways to find it. I could use vector projection right here. Which, I would obviously use vector projection of F onto V. So, this would be F dot V over the magnitude of V squared times vector V. And that would work just fine to give me my answer. My answer, if you do this, ends up being 150 over 13 and negative 100 over 13. Now the best thing to do to find the component perpendicular, actually, right here, is to understand that these two vectors x and y have to add to be vector f. So, what I found for vector x, what I called x right here, and then plus what I'm going to find for vector y, which I don't know the components x and y, has to be equal to vector f. And so if you set up this equation, then it's easy to find what x is. X has to be the opposite of this, so that when you add the x components, they cancel to 0. So obviously this has to be negative 150 over 13. And then to find the y component, I have to add the y's together. So I have to do this plus this and set it equal to this. So negative 100 over 13 plus the y component has to add to negative 25. So just add 100 over 13 to both sides. You end up getting as a fraction, if you do the common denominator, negative 225 over 13. So that goes here. And that will give you this vector right here. And then last, to find the work done by force F through displacement V, we want to use work equals force times distance. The force that we're using is the component that's parallel to vector V, which we already found here. And then the distance that we want to use is obviously the distance that displacement vector V is, so the magnitude of vector V. And that will give us our answer if you just multiply square root of 13, keep that in the numerator. I'm going to make problem 11 extra credit as a challenge problem. We can try to do it in class if you want, but you do not have to do problem 11. Now problems 12 and 13, we can do the same thing. We'll make those extra credit. We can try them in class if you want, but they're a little bit too difficult for what I'd ask you on a test.